Welcome to today's webinar brought to you by Dremio and AWS. I'm Stephen Fagg, Director of Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, A Modern Architecture for Interactive Analytics on AWS Data Lakes. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Now, to introduce our speakers for today, we have Roy Hassan, Senior Manager of Business Development, Analytics, and Data Lakes at AWS, and Gabe Jacobson, Senior Solution Architect at Dremio. Now I'm going to pass the event over to Roy.
Hi, everybody. Again, thank you very much for the introduction. Just quickly, again, my name is Roy Hassan. I lead the Analytics Specialist team at AWS. I've been working with a lot of different customers around building data lakes and modern data architectures for the organizations to really help them become more data-driven organization. So in talking to our customers, the problems and the challenges that they portray around why they want to build a data lake and kind of the value they want to get out of it really center around two main areas. And I try to kind of present this here in the slide. The first one is, how do I let my users, my personas, be able to be more self-sufficient, get the job done, find the right tool, and just be very efficient, right? Just get the work done without having to rely on too many other people to get their job done. So that's kind of one aspect of it. The other aspect is, from an infrastructure perspective, we still want to make sure that we're following best practices, that we're not building ourselves into a corner, and that we're using technologies that are scalable and easy to use, and ultimately be able to deliver the features that our personas really need. So when we're talking to these different personas, they obviously have different requirements. But when you talk to the infrastructure team or the IT team, they want to make sure, right, there's no data duplication, which caused the original sort of data silo problem, that the tools are easy to use. There's not a need for the infrastructure team to spend a lot of time benchmarking and configuring and tuning and testing and monitoring, that everything just works, right? And also it's scalable, right? So as you add more data, as more users come in to use the platform just automatically scales with it. So those are the two big challenges that we're going to try to address with a data lake approach. So just kind of taking just like a stepwise approach, we typically start with a data lake. We start with an Amazon S3 as our storage layer. It's scalable, highly durable, highly available, great integration with APIs and all the other services out there. So it's a great place to put the data. Now, the big benefits here is, we reduce duplication. We got a central location for all of our data. There's no more silos. We can manage it in a central place, right, through IAM or through other policies that are managed in a central team, or even if we distribute it across different teams, it's still, basically one platform. Like I said, it's well integrated and it's really cost effective, right? There's a lot of features that help you do the intelligent tiering, right? Move hot data as it becomes colder, move it to less expensive storage so you can save money. But also, you put data in compressed formats, and now you save yourself on that, et cetera, et cetera. So there's a lot of options there. So that's a great platform for us to store our data. So the next thing that we want to do is, once we have the data in S3, for this data lake to actually be meaningful to you, we want to be able to catalog it, right? Extract the schemas, extract the information about the data, about the files, into a single yet decoupled layer that we call this decoupled metadata layer. And we have a service called AWS Glue Data Catalog that's Hive compatible, which means it's going to work with the same big data engines that you know and love, like Spark and Presto and Hive, etc. But it's fully serverless. It's fully managed for you. It's decoupled from the compute engine itself. So you can use it as a single layer to be able to discover which data sets are available for you in S3, but also provide integration at the metadata layer to other systems. And you'll hear how Dremio kind of plugs into that as well. So again, it enables ubiquitous access to the data. central management of metadata. So you can come in, you can find all the data sets that are available for you. You can plug into them right from there. And it enables that ecosystem of partners to come in and give you additional functionality. If that was baked into an existing data store, it would be very hard to integrate with. And that's kind of the challenges that existed with a Hive Metastore in the beginning. There weren't really a lot of good APIs, and you didn't really see a lot of good integration outside of the Hadoop ecosystem. So with the Glue Data Catalog exposing all this metadata through APIs, now we open up the ecosystem. So it's a really powerful way to future-proof your platform. Moving up, the next kind of layer in your data lake is how do you control the authorization and access policies to that data, right? You can set policies on your storage, right, on S3. You can set policies on your catalog, on your metadata, right, such as, you can list this table, but you cannot read it, or you can read it but not write into it. The same goes for data in S3. But how do we do it in a way that's easier to do, easier to manage, right? I don't want to use IAM policies. They're great, they're very flexible, but it's a little bit more challenging. So lake formation is an authorization layer that sits on top of your data lake in S3 and allows you to define fine-grained access controls to your data. So you can say, Roy has access to table users, column 1, 2, and 7, but not the rest of the columns. So that's a really powerful mechanism to implement both governance, so we know who's accessing what, we have audit on top of that, and also the fine-grained authorization. So with that, you also have a way to better discover your data. You have the central governance and authorization I talked about. It's auditable. And the last piece is that it also enables what I call kind of the universal data sharing idea. And you see tools out there that, databases or systems that say, hey, we can share data between our systems. And that's awesome, right? You can share from one data warehouse to another, from one query engine to another. But how do you do it in a more universal or generic way? And lake formation allows you to do it, right? So you can say, hey, I got a table here registered in my catalog that maybe sits in my dev test account. I want to be able to share that with another account. Or maybe I have data sets in my production account and I want my dev test account to have access to it, right? So I can easily, through lake formation, say, take this table and share with this other account, and then you control all the access to it. So it's really powerful, and it doesn't depend on any upper-level tools to be able to give you that sharing capability. You get it right out of the box with this data lake. So at this point, we built a foundational data lake, right? This is what a typical data lake would look like. The next step is, and you probably hear a lot about kind of lake house and what does it mean. But now that you've built a data lake, and you can see this in the box in the bottom, the 3 layers, that's the foundational data lake. Now on top of that, you want to be able to bring consumer applications, right? Those are systems like Amazon Athena that runs, queries on S3. That may be Amazon EMR with Spark or Presto to be able to analyze that data. Even Amazon Redshift, if you wanted a unified kind of query engine for both data inside of a data warehouse, but also in your lake. That allows you to plug into this data lake, right? So that's kind of the concept of a lake house. Now, there are many different tools and capabilities, right? So Athena it's a query engine, right? It's not a database. It doesn't store any data, but it allows you to interactively work with the data in place that is very cost effective. But compare that to a data warehouse. In a traditional world, a data warehouse, everything will have to be loaded into the data warehouse, and that's where you use the data. But in this lakehouse world, that concept is now decoupled, right? Now you can still put data in a data warehouse, but think of that as more of a cache, right? It's something that stays there for a little bit just to be able to serve the queries, where the remainder of the data resides in your data lake. So this whole lakehouse platform is a lot more flexible. It's portable. The data sharing that I talked about allows you to share data between all these different systems, and really eliminates the lock-in aspect of any one solution that controls the full platform end-to-end. And then lastly, if we kind of talk about where does Dremio kind of fit in, again, it's both a query layer, right, that's able to access the data, and you can see by the arrow here, be able to kind of connect to the Glue catalog that I mentioned before, that allows us to plug into the lake directly. So you can come into Dremio, you can be able to query the data right there, but you can also layer capabilities on top of it if you wanted more flexibility to be able to give your users a self-service way of accessing the data. Now, compare that to a data warehouse. It's not a data warehouse, right? It's more of an intelligent query engine. In the next section, we'll dive deeper into that. But if we were to kind of take a step back to the original problem statement that I called out, from an infrastructure perspective, the data lake that I showed you here is flexible, is scalable, is highly available, it's cost effective. It eliminates a lot of the complexities of data duplication. It makes access to data. And then how do I help my personas? That's where the best tool for the job comes in, whether it's Dremio or it's Redshift or Athena. There are different use cases where one is better than the other. And then on top of that, you layer your visualization, your machine learning, your studio experiences, your user interfaces to be able to interact with the data. So that's, very quickly kind of like what a lakehouse architecture is, right? Data lake is the foundation, plug in data consumers and visualization and user interfaces on top of that, and that extends the data extends the data lake into a lakehouse architecture. So from this point on, I'll hand it over to Gabe, and he'll kind of walk through what Dremio is and how does it plug into this. Gabe, you want to take it away?
Absolutely. Thank you, Roy. So let's kind of build on what Roy has just said and talk about Dremio's vision for a modern data lake architecture, specifically from the perspective of analytics. So if we kind of step back for a minute and look at the whole problem from a data consumer-centric point of view, data consumers are not necessarily happy in this day and age of exploding data. If you're a data consumer, in many cases, you may be experiencing slow queries and or slow time to insight. Why is that? Well, if you have very, very large amounts of data, say, for example, in a data lake or a very large data warehouse, in some cases, you could not run fast queries against very large data sets, right? So live queries get slower, and if you want to extract data using a product like Tableau or Power BI, there is a limit to how large extracts could be. What's more is that extracts actually produce a delay, right? So you have a certain slowness in time to insight, because if you're extracting data, naturally, the whole process, in fact, if you look at this little ETL pipeline here, it's not really ETL, but for all intents and purposes, if you take data that currently exists in your data lake and you try to chunk it out into data warehouses, so it's optimized for analytics, and then you try to cube and aggregate it and create all kinds of insights, this is a lot of work for IT. And from the perspective of a data consumer, it slows down your time to insight. So this may sound a little bit trivial, but I always get surprised by something that's, I think, fundamentally different between data warehouses and data lakes, and something that people kind of ask and a lot of times don't take time to meditate on. So if I gave you a value, right, I just typed a number here, what is this value? It could be one of many things, right? Maybe it's my revenue for the year. Maybe it's my revenue per quarter, I wish. We don't know whether it's dollars or pounds. Maybe it's not a number at all. Maybe it's somebody's social security number. So in the world that's existed for the past few decades, in a pure classic data warehouse world, this value has a very specific definition. We know, for example, that this is an employee social security number, and we know what table it lives in. We know it's a varchar. We know it can have exactly, however many 10 digits. We know how it relates to other data. These are all things that we take for granted in a data warehouse. A data lake is different, right? In a data lake, to those of you who have played with S3, which is wonderful, you have a bunch of buckets, and you can throw anything in there, right? It could be a movie, it could be a picture, it could be data, right? So this number or this value doesn't necessarily have a natural meaning in a data lake. We have to assign a meaning to it, and then we can query it and build, analytics on top of it. So in order to make a data lake really useful for analytics, we need a few things to exist. data has to have a meaning, right? That number that we saw before could be a part of a movie stream, right? It has to have an actual meaning of what that number is, if it's even a number. It has to relate to other data, right? The nature of analytics is such that usually you want numbers to relate to other numbers, measures to relate to attributes, right? You're not dealing with just, a single element. You need to be able to use SQL, right? The most common language of querying data generally. And that SQL needs to preferably run at speed, right? You want your data consumers to be able to execute queries very fast. So what does Dremio do? And we'll kind of dive deeper into this. So we can query S3 directly with 4 times performance, and this number varies. This number could actually be dramatically larger than 4 times with minimal data movement. That's really important. Most of your queries are actual live queries against your data lake via Dremio while you maintain control of your data. So your data doesn't migrate or move anywhere else. So that your data is your data, and Dremio kind of sits on top of it as an engine. And I will show you a schematic diagram. In fact, there it is. So imagine your data lake, S3, Glue, down here at the bottom, and all kinds of external data sources, which we'll talk about a little bit as well. Up at the top, you've got your data consumers, your data scientists, your BI users, etc. Now, in the middle, you've got this invisible, from a end user's perspective, invisible data lake engine, which gives you speed, but it also gives you a semantic layer. So from the perspective of BI users, for example, you want consistent business logic, right? BI users are no data scientists. They're not just playing with data. They need to be able to present reports and KPIs, and those need to be consistent and accurate. You don't want to wait for IT to keep on ETLing your data, right? As an end user, you want to be able to access it directly. You want to be able to discover data and share it easily. You also want, from an IT perspective, you want to make sure you have good data governance, right? Security and governance are key, especially when it comes to PII data. You don't want reactive CDS work, and you want easy collaboration. And this is something that Dremio provides you with. That's a value that Dremio provides. So what you see here is AWS Glue. So the first step in creating a semantic layer is leveraging AWS's Glue as a data dictionary, right? So if you remember that large number that I had before, large value, so leveraging AWS Glue, the value gets a meaning, right? So AWS Glue crawls your data lake and understands what the various tables are. Tables are typically comprised of thousands, sometimes tens of thousands, maybe even hundreds of thousands of small partitioned files in your data lake, right? So it's really important to have AWS Glue as one avenue to catalog your data and help Dremio understand what your data is at a very granular level, very fundamental level. This is not business logic. This is more like, what's a particular number? Is it an integer? Is it a varchar? What file does it, where does it live on disk? So the next step about that is Dremio semantic layer. So once Dremio, and I'll show you a demo screenshot of that, but once Dremio is connected to Glue, and once Dremio has sucked in the data of what your data is like in terms of tables, then it's time to really assign a business meaning to it. And you can't really underemphasize the importance here. The idea that while you may have lots and lots of different tables in your data lake that are called, all kinds of tables that have revenue in them as a column, right? Revenue is just a name. If you're a CFO of a company, revenue has a very specific meaning to you. And so you need a semantic layer which assigns that business meaning to a number that just lives somewhere in your data lake. So in terms of a demo, in terms of logistics, just passing screen share, it wasn't very practical for this presentation. So I've taken a couple of screenshots, and to anyone who is interested in seeing the product in a real demo, sign up with us with Dremio, or you could actually download, or you could actually fire up Dremio on AWS and start, or AWS rather, and start using it yourself. But this is Dremio's IT view, right? So if you're a data consumer, you would not see this. But if you're a data engineer, if you're in IT, this is something that you would see. Down here at the bottom, we've got data sources. So you could connect to any data lake out there and most other RDBMSs or other data sources. In this particular case, we chose to connect to Glue, right? And once we have connected to Glue, AWS Glue gives us a list of all the tables which it discerned from the underlying data lake from S3. Double-clicking on any one of those tables, Dremio opens up the table and treats the table as analytical data, right? So it treats a table, it treats a file that lives on S3 as a real table. If you, as a data consumer, if you were then to fire up Tableau or any BI tool connecting it to Dremio, in this particular case, a little icon here, the Tableau icon, click on it and Tableau fires up. So from a Tableau perspective, all of the dimensions and measures that were discovered by Glue and curated by Dremio become available to you for dragging and dropping. And this is really something that's worth seeing live, because if you were to drag and drop attributes and measures, you would be able to create charts, ad hoc charts, lightning fast, right? So for example, creating this chart in terms of actual data reads only takes about a second or two. So as an end user, right, as a BI user, you just drag and drop attributes and measures, and even though, if you look at the previous slide, even though there is over 1 billion records in this particular table, being able to do all kinds of ad hoc analytics to it only takes seconds. If you're a Tableau user, this feels to you as if you have an extract that lives on your hard disk, right, on your Mac's hard drive or PC's hard drive. In reality, though, everything that happens here happens via Dremio. So this is the Dremio, now we're back to the Dremio console. This is what your data engineers and this is what IT would generally see. Any query that Dremio receives, for example, from Tableau, gets registered with Dremio. Dremio analyzes the query, plans the fastest route to execution, speeds up the query along the way using about a handful of different technologies, and then returns the data back to the Tableau user extremely, extremely fast, in most cases under 1 second. So when you actually test drive Dremio, what you will see is the speed. So let's talk about interactive analytics. What gives us the speed, right? So we understand metadata or the metadata layer. Let's talk about speed. So I mentioned in passing about a handful of technologies that allow Dremio to really achieve that kind of crazy performance. 4 times speeding up of ad hoc queries, up to 1,000 times speeding up BI dashboards or things that could be cached. So reduce infrastructure costs, we'll talk about that a little bit. But the idea of speed is Dremio as a company started a project, an open source project called Apache Arrow, which has become one of the most popular Apache open source projects out there, 15 million downloads a month. So if you look at what Apache Arrow does with your data in MEM, if you look at our ability to have a scalable, scale out, scale in MPP engine that predictably queries your data lake, if you kind of put everything together, you get tremendous speed. I don't want to dwell on every one of, I could talk at length about every one of these different technologies, but generally speaking, this is how we achieve speed. Also, elastic scaling is really important in terms of cost. So we have the concept of engines, and when we sense that there is, or when a certain condition is met for us to expand our execution engine, we do so transparently to you and automatically. So if you have a flood of queries coming in, we could fire up more executor nodes. We crunch through your queries and then scale it back down so that you save on cost. Many analytics workloads are ideal for data lakes. A lot of these you could just imagine. Things like dashboards and report acceleration, we talked about this, that's ideal, and ad hoc query acceleration, ideal for data lakes. If you're a data engineer, again, data lakes are ideal for you. And if you want a standardized semantic layer, and so, that's something that we talked about at length, let's not forget our data scientists, right? There is more and more data science out there, ML, AI, data exploration, feature engineering, which is real important and could be a rather painful process. This is where, you know, if you're an AI practitioner, you need to be able to scan over millions of different data points and engineer them in all kinds of ways to build a predictive model, right? So this is something where data lakes are making a big impact. In terms of migrating workloads, so if you have an on-prem data warehouse, this is really a good time to migrate some of the workloads, if not all the workloads, at least some of the workloads, start migrating them to the data lake, especially the non-transactional workloads. We have support for transactional workloads coming up, and if you guys ping Dremio separately, I can explain what the difference is. But for right now, the majority of all of your non-transactional workloads, your normal data is definitely a good candidate for migration from Teradata and other on-prem solutions. Same thing with Snowflake and cloud offerings. If you have a data warehouse in the cloud, it's really ideal to start saving money. Just take some of the data, migrate it over to a data lake, and leverage both AWS for data lake and Dremio to speed up your queries and create a semantic layer. Great use case. Another point that I want to make sure that I touch on is that it's not an either or, right? It's a world of coexistence. We understand that data warehouses are not going to disappear overnight. It's not the case. It's not like you're going to, you know, turn off your lights on a data warehouse on Friday, do migration to data lake over the weekend, turn on the lights on a Monday, and 100% of your data is in a data lake. That's not going to happen. So another good thing about Dremio is the fact that we support that type of coexistence. So when we connect both to data lakes, obviously, and also to external data sources, to your regular RDBMSs, to Amazon's Redshift, or to Teradata, or Snowflake, or any other data warehouse, and we can federate queries between the two, so that if you have actually started your data lake journey and you have migrated some of your data to a data lake, your users could submit a query to Dremio, and the query could be satisfied by some answers that live from the data lake, and some from your traditional data warehouse. Dremio would then understand the query, federate the query correctly to both sources, combine the result set, and give you back the result extremely fast. So how do you get there? These are just some tips, right? We have, I think the next slide is going to show some of our, impressive customer list. So how do you get there? Just generally, what do most people do? Well, if you already have a lot of data lake presence, then you're ready. If you don't, maybe start by migrating some workloads to your data lake, right? Just if you're receiving new data, if you're re-architecting your data warehouses, take some of those workloads, put them on the data lake, and have the two paradigms coexist. Don't boil the ocean, right? Start with some data, some use cases. Maybe, gather some specific use cases, and Dremio can help you with that. Let's get those use cases to work and prove themselves, and then we can move more data to your data lake. And really important, make it transparent to your BI users. You never ever want your BI or data consumers, you never want them to suffer for your back-end decisions, right? You only want them to benefit. So make sure that as you do this migration, make sure that the performance they realize from data lake exceeds their expectations and is transparent to them. Just as a summary slide, real impressive, and this is a very partial list of some of our large customers out there. Once again, lightning fast, if there are two things to remember about Dremio. Lightning fast queries, right? Dramatic acceleration of data lake queries, and a self-service semantic layer, which means that you can provision data sets very fast, you can share them, and really important, there is zero lock-in, zero loss of control. With a lot of solutions out there, primarily data warehouse solutions, you are uploading your data somewhere else. You are uploading your data to somebody's data warehouse, and then you lose control of your data. With Dremio, your data stays in your data lake. Dremio touches it to execute queries, but never moves it. How do you get started? You can try our AWS edition for free. Just just Google AWS Marketplace Dremio, and you're going to see a screen that looks like this. And you can just fire up either the normal trial Dremio or Dremio Enterprise, which has more security features, and start testing it out. It takes very little time, and it's real fast. And over to you, Stephen.
Thank you very much, Gabe. So we're going to dive into questions from our viewers. First question, how does Dremio make Tableau faster?
Yeah, absolutely, Stephen. So we kind of saw it before. The whole idea is that when Dremio receives a Tableau query, Dremio has about 5 different techniques of executing the query faster if it's a live query. One of the techniques is called a reflection. So we can materialize if we see a query that's very repetitive in nature. We can use our proprietary technology to materialize the results of that query and reuse it for other queries. That dramatically speeds up your Tableau experience. But in general, the fact that you don't need to wait for Tableau extracts to happen, the fact that you could create and execute live queries against Tableau and get the results fast is what the Dremio experience is.
Understood. Thanks for clarifying, Gabe. Next question. I heard Dremio reflections are really fast. What are they, and do I have to use them every time I want a query to run faster?
Sure. So Dremio reflections are a super useful technology, right? It's really impressive how fast they really are. However, I kind of think of them as almost like an afterburner on a fighter jet engine. I understand this is not an analogy everyone would get, right? But the idea of a reflection is that Dremio natively, without reflections, is super fast. In some cases, it makes sense to further accelerate particular query patterns, and that's where reflections come in. So Dremio is fast without reflections. Reflections are useful in places where you want that extra oomph to execute queries.
Understood. Moving to our next question. Can Dremio run queries that read data both from a data lake and a data warehouse at the same time?
Absolutely. Absolutely. So when Dremio understands your underlying data, right? Dremio understands that some of your data, hopefully the bulk of your data, lives in a data lake. Dremio understands what data lives in data warehouses. Dremio has a slew of connectors into data warehouses. We also support your writing your own connectors, right? So we have a Dremio hub where you could create your own data warehouse connectors. Dremio receives the query, analyzes the query, and then federates the query out to either the data lake and or your standard, your data warehouses, fetches the result set for both, combines the result set, and gives you, as an end user, the answer.
Understood. Thanks, Gabe. Our next question, we have someone that's curious if there are other AWS services that integrate with Dremio, and what if data is stored on EFS or FSX, Lustra, can Dremio be used? Yeah,
sure. So I can answer it, Gabe again. And Roy, I don't know if you want to take a crack at that as well, but from a Dremio perspective, data is data, and as long as we can get to the data, we can work with it. So Dremio actually makes use of EFS on its own. A lot of the question becomes not about whether Dremio can get to the data. The answer there usually is yes, just because you're using pretty standard JDBC drivers and or API, so the data can always be gotten to. The real way to answer this is whether that's an ideal architecture. So for example, EFS is a place where you could store data, but it's not ideal for analytics. It's not built for speed, right? For analytical query speed. So that's where we would work with you and kind of encourage you to think about real data lake architecture and maybe shifting your data over to S3, just to make the whole process more efficient. But can we read from it? Absolutely.
Understood. Moving to our next question, we have someone that's curious about whether compute costs, what they would look like using Dremio. I'm not sure if that's something you can really get into. It's probably specific to each environment, but I don't know if there's anything you could say around that.
Yeah, no, it's a good question. It's a question we get a lot. So compute costs. So what we try to get to is that to a certain extent, you kind of pay for what you use, or we try to, let me phrase it differently, and I'm really not the, I'm not the account exec who usually talks about pricing, but what we try to do overall is we try to align compute with cost. So when you think about data warehouses, you're typically paying for both. When data lives in a data warehouse, you pay for that whether you're crunching through queries or not. The paradigm with data lakes is that your data lives on S3 for a very low price point. I think it's like $20 per terabyte or $20 a month. Extremely low cost, right? So it doesn't cost you that much to have your data hosted on S3. What does cost you money is compute, right? And so what Dremio tries to do is, since Dremio is the compute portion, right? So when Dremio receives queries, Dremio fires up a compute engine that actually executes on the queries. That's a cost that's a real cost. And so what we try to do is we try to address it via workload management. So you could decide on the priorities of various queries and align those queries with various engines, in quotes. An engine is a collection of nodes on EC2 nodes, which Dremio manages on its own. So if some queries are really important, we can fire up larger engines for you. Those are more costly, but queries would typically execute faster. In other cases, we can put those nodes, we can stop those EC2 instances so that you would save money when you don't need the execution engine. So we've put a lot of work into that specific aspect of saving you money by controlling your compute costs. Hopefully that answers the question.
No, thank you very much, Gabe. I appreciate it. Next question, can Dremio run queries in a hybrid cloud?
Yes. So the yes comes with a bunch of caveats, right? Well, the answer generally is yes. We're designed for that. In terms of best practices, we have to look at it more closely. In fact, most of our large clients do have something of that nature, right? In today's day and age, it's pretty unlikely to have data live only in one place, right? If you talk about Fortune 100 companies, everyone, well, not everyone, but most of them have some kind of an on-prem, data presence, and they every once in some of them, stick to AWS, but some have Azure. So the answer is yes. But it's something that we should discuss architecturally. In other words, what actually makes sense in order to reduce cost and increase performance. Understood.
Next question. Any tools, drivers to move data from legacy systems like IBM iSeries, DB2, to a data lake?
So if the question is for Dremio, the answer really is no. Dremio doesn't really get in the business of ETL, of moving the data from point A to point B. There are a lot of great tools out there that I can't remember whether maybe you could actually use, and that's more Roy's department, but maybe something in the EMR world of AWS would make sense here. But from a Dremio perspective, no. From a Dremio perspective, we only deal with the data once it's in the data lake. We can give you a lot of great advice on how to move your data, but we're not in the business of actually moving the data to the data lake.
Yeah, and that's a good point. I mean, there's definitely a number of tools there. I think if I was to look at the AWS ecosystem, the first one that comes to mind is AWS Database Migration Service, which allows you to bring data from a number of different database sources into S3, right? Writing it in Parquet format, so it's ready for Dremio and other tools to query. There's a service called Amazon AppFlow that brings data from SaaS providers like Salesforce, etc. So that's another option. But we also have a number of ISV partners similar to Dremio that are in the space of bringing connectors for a number of different things, such as Fivetran and Informatica and Talent. So there's a number of ways to bring data in a structured way that will end in S3. Once the data is there, you can do a lot of stuff with it in S3 and prepare it for Dremio to consume.
Understood. Thanks, Roy. Our next question, are there scheduling options available in Dremio?
Scheduling options in as far as, I think I need some more context.
Okay, if the person that asked that question can follow up with additional context, we'll try and get you an answer. So moving along, next question, are there additional benefits that someone could get by having Dremio on top of Snowflake?
So Dremio on top of Snowflake is possible. Where we see that is we're not really on top of Snowflake as much as a lot of your data lives in the data lake. However, you're also paying for Snowflake, and you have some useful data in Snowflake, and we can bridge both, right? So we can query your data in the data lake, which is Dremio's reason for existence. However, we can also access data in Snowflake and federate queries to Snowflake. But we would not live on top. So the question is, the answer would depend on what you mean by on top of. In other words, we could read data from Snowflake, and we could accelerate. We could use reflections to make some Snowflake queries faster. However, we don't position ourselves as living on top of Snowflake. It's just a data source for us that hopefully in the future will get migrated to a data lake.
Understood. Thanks for clarifying, Gabe. Okay, so we're getting close to the top of the hour. So at this point, I just wanted to offer both you and Roy an opportunity to just deliver final remarks, what you'd like our viewers today to walk away keeping in mind. And Gabe, we can start with you.
Final remarks. Well, I think that most companies we talk to either have a data lake strategy or formulating one. We would definitely encourage you to talk to Dremio. We're very easy name to remember or easy to Google. Look us up. Fire us up on AWS. Try us out. Contact us as a company. Ask us questions. We're real good at giving it, right? So we're real good at helping you kind of shape your data lake architecture. Data lakes, it's not just a matter, if you remember some of my earlier slides, data lakes and data warehouses are not the same. You can't just take data from a data warehouse, dump it into a data lake, run the very same query, and be right. There are some nuances. There are differences between both. We can help guide you in that journey. So absolutely contact Dremio. And thank you so much. Thank you for attending.
Okay, and Roy, any final?
Yeah, no. I think one thing that I want to make sure that folks kind of take away from this whole conversation is that in the days prior to kind of what we call a modern data lake architecture, to solve data problems, you typically take the data and you put them into a tool, right? Whether it's a database or a data warehouse or on-prem Hadoop or whatever that may be. That was a quick way to solve the problem, but it was not a scalable problem. What we see now is customers are really struggling to get out of that mode and into something more scalable and more flexible. So when kind of reevaluating building a modern data architecture or modernizing what you already have today, think about the decoupled approach that we talked about today, right? Starting off with a data lake using Amazon S3 and Glue as a way to save the data, store the data, catalog it, and expose it. So then you can open it up for a lot of different tools, whether it's Dremio or Redshift or Athena, whatever you end up choosing, to be able to consume the data rather than being locked into one particular solution just because it's a little faster or it does something better. So Dremio plugs into a data lake story really, really well. So I think Gabe did a great job at kind of talking about the benefits. But what I want you to take away is that you've got to start with a foundational data lake. If you don't have that, the rest is going to be much, much harder to do, and then you end up, painting yourself into a corner. So again, just kind of make sure that when you're building a modern data architecture or data lake, start with a foundational data lake and then layer these new capabilities and Dremio on top of that.
Thank you, Roy. I'd like to thank both speakers today, Roy Hassan, Senior Manager, Business Development, Analytics and Data Lakes at AWS, and Gabe Jacobson, Senior Solution Architect at Dremio. As I stated earlier, all questions will be answered via email. If you would like to review this presentation or send it to a colleague, you can use the same URL that you used for today's live event. It will be archived, and you'll receive an email once the archive is posted. Thank you again, everyone, for joining us today, and we hope to see you again soon.